Hello friends, today we'll be doing an LED headlight install on the 6th generation Mitsubishi Mirage. This tutorial covers vehicles made from 2012 to present. This tutorial is only for people who have the reflector style headlight housing and not the projector style headlight housing. The projector style headlight housing, also called the xenon light housing, is only for the top trim Mitsubishi Mirage, the GT trim in North America. The headlight I have decided to go with is the Philips Ultinon Extreme Gen 2. This is an H4 or 9003 bulb style. This bulb goes for around $263 for the pair, Canadian. I will also be showing you a competing bulb, which is very popular on Amazon, the SEALIGHT LED headlight. It's about 50 Canadian dollars, and we will briefly compare the two. The most noticeable difference at first glance between these bulbs and the SEALIGHT ones is that the driver for the light bulb is separate from the LED. On the Philips, there's a connector between the two. On the SEALIGHT, they're permanently attached together with a cable. On the Philips, the heatsink unscrews from the bulb itself. That's why the heatsink on the Philips is larger than the SEALIGHT. As you can see here, I had a very tough time unscrewing the heat sinks from the bulbs. It appears they had some type of thermal compound to just help carry the heat from the bulb through to the heatsink, which was making it tough to unscrew. I would like you to pay close attention to the reflector you see kind of half moon shaped near my left thumb. The LEDs within that reflector are the low beam, and the LEDs to the right of that reflector are the high beam. Also take note that when trying to unscrew the heatsink or just working with the bulbs in general, you should never touch the LED drivers themselves with your hand, as the oils in your finger on top of the LEDs will shorten their lifespan, as it'll cause them to overheat as the light will reflect off of the oils. This is why some bulb manufacturers such as SEALIGHT, as you'll see later in this video, provide you with a pair of cotton gloves. As you can see here, to unscrew the heatsink, I ended up having to hold the base of the LED with my t-shirt, as the flat piece of metal is very sharp. If you've ever wondered why there's 3 tabs on the base of these light bulbs, I will be explaining that shortly as well. Here I will unbox the SEALIGHT bulbs I also bought. The price differential between these bulbs is crazy. The SEALIGHTs are less than a fifth of the Philips bulbs. I think I opened the box upside down here, but the SEALIGHTs, as you can see, the driver is fixed to the bulb, and the heat spreader on the bulb is not removable. Instead, the plastic base of the bulb twists off. Here you can see this bulb is a very similar style to the Philips. There's also the half moon reflectors on both sides for the low beam. Another set of LEDs closer to the base for the high beam. So you can see here the base just has a half turn until it comes off. It's kind of different. It's very hard to compare these two bulbs, as the key factors I don't really know. I don't know who manufactures the LED. I don't know how the driver is designed. And I can't really compare the heatsink material or the thickness of the PCB, as a thicker PCB is much more desirable, as it'll carry more heat. There's no easy way for me to measure that. So remember earlier I showed you that both those LEDs had the half moon low beam design. If you're wondering why I put so much emphasis on this, it's because of this diagram from the owner's manual. As you can see, the low beam is only supposed to send light upward towards the top of the reflector, and the light is supposed to go downward. That's why it's called a low beam, because the light is angled downward. This is so that you don't blind other drivers that are driving towards you. This is also why the base of all our light bulbs have those 3 tabs I mentioned earlier. It's to ensure that the reflector for the low beam is always pointing upward, and that you don't inadvertently install the bulb incorrectly. Here's the diagram from the owner's manual of the high beam on. You can see it's kind of closer to the base of the bulb than the low beam, just like the LEDs we bought. Obviously the goal of the high beam is just put as much light down the road as possible. Here's an example of an LED headlight you should not buy. The low and the high beam use the same LEDs, and there is no reflector. So even with your low beam on, you'll still be blinding other drivers on the road. It's really stupid. You should really avoid doing it. To give you, my viewers, an idea of how much light these bulbs put out, I will be keeping the car stationary approximately 1 meter away from the wall, and I will be turning the lights on and showing you the reflection against the wall so that you can kind of compare the bulbs. Here you can see me turn on my parking lights. They're aftermarket Philips LEDs, but they're only 5-watt bulbs. Still really put out any light as the garage is already very well lit. You can't really see any reflection off the wall. Here's me turning on the low beam. Note that very clean horizontal line. That's caused by the reflectors built into the bulbs, shining the light downward towards the ground. Here you can see me flashing the high beam to show you the difference. So we can begin the install now. The headlight connector is of course behind the headlight. It's the only one where the cables point downward. There's 3 cables, purple, red, and black. One of them is the high beam positive, one is the low beam positive, and there's a common ground cable. If you can't get the connector off with your hand, I don't recommend yanking on the connector as the bulb is only held in with a spring and you may damage that. Here you can see me jamming a flathead screwdriver in between the connector and the bulb to work the connector loose. This is a little bit difficult for me to do because you can't actually see where the connector meets the bulb. The connector is inside of this rubber dust boot. I'll show you a close-up photo of it later. If you're wondering why the connector is designed the way it is with the cables pointing downward, it's actually to completely idiot-proof the orientation of the bulb as we spoke about before so that the low beam always points downward. Here we can see a close-up of the connector I just removed. It plugs directly into the back of the bulb. Now we will remove the rubber dust boot covering the bulb. 2 convenient tabs are provided for removal. One's located here and the other is located here for you to pull on. Once you've got the rubber dust boot out of the way, we can now remove the bulb by pushing in on this metal tab located here and pulling up. Once it's out of the way, the bulb just comes right out. As you can see on this halogen bulb, it also has the low beam reflector half moon thing that shines the light upward. And it has the high beam directly below that, just like our LEDs. Now we're going to install our Philips LED bulb. Note that the reflector half moon thing is pointing upward. There's also text on the front of the bulb that says Philips when the bulb is in the correct orientation. And the tabs on the base plate also help you. Once you put the bulb in, you just close the metal wire thing over top to hold the bulb in place. Again, I promise I will show a close-up of this later. Once you've got the bulb installed, you will work the dust boot on over the bulb. Once we've got our dust boot in place, we can screw on our heatsink. Through the powers of video editing magic, you will see me screw this on at superhuman speed. Now we will connect our LED light to the separate LED driver, which you can see me holding in a bag here. The connection between the cable for the LED bulb and the driver is kind of interesting because it has a threaded cover that ensures a good seal between the two ends of the cable. And the other end of the driver will of course plug into our headlight connection. Here's a good photo of what it looks like assembled. Pay close attention to the white bolt and the other bolt on the bottom right diagonally apart from each other. So we're talking about that briefly. So as you can see in this diagram from the factory service manual, those two bolts I just pointed out are used to adjust the headlight's angle. It's mostly for the low beam. So if you're in an accident and your headlight is bent upward, you can adjust it so that that horizontal line is in the correct position so that you're not blinding other drivers. Generally speaking, I'm way too lazy and this is very complicated to adjust, so I don't really mess with it. But professional body shops, collision centers will do this. The bulbs will never naturally fall out of alignment, so I don't really see a need to talk about how to adjust these. But normally you'd park like a certain distance from a wall and you'd use the mathematical ratio given in the factory service manual to figure out how high off the ground that horizontal cutoff line should be, and then you'd also have to adjust the bulbs left and right. Now that we're finished setting everything up, all we have to do is figure out where we want to put the driver. Zip ties were included in the box for this Phillips kit. SEALIGHT gives you zip ties and some double-sided tape if that's what you prefer. I will show you where I mount mine shortly. Here's where I've decided to mount mine. It's just a single zip tie to the frame. I have no idea how hot this driver is going to get, so I'm not too sure how to decide where to put it. Some LED headlights, like I think the newer Philips Pro 9000 headlights, they don't have an external driver. It's kind of one with the bulb. Kind of has its pros and its cons with regards to heat dissipation. Here you can see I haven't moved the car from the previous test. I will now show you a comparison between the Philips Ultinon Extreme Gen 2 and the stock factory halogen bulb, whatever was already in here. As you can see, the difference is very big. The halogen bulb has a slight warm-up time, which is not really a big factor in any type of decision making for headlights, but you can see that with our low beam, the Philips bulb has the same cutoff line that we desire so that we don't blind oncoming drivers. You can see me flash the high beams. Philips is clearly brighter. Here I've installed the much cheaper SEALIGHT bulb in place of the halogen bulb. You can see that the SEALIGHT bulb on the left, the Philips bulb is on the right. It's kind of hard to say the brightness difference, but the SEALIGHT, of course, appears to have a wider beam in person. They both appear relatively equally bright, but generally speaking, I can't speak for long term how well these bulbs will perform with heat, whatnot. I'd like to put a lot of emphasis on the fact that the low beam still has that horizontal cutoff line we desire. You should not buy those stupid LEDs without the reflectors. Here's a close-up of the mechanism that holds in the headlights that I promised you. As you can see, it's kind of like a steel wire that's in the shape of a U. The bottom leg kind of acts as a spring that applies constant pressure to the bulb. The top leg that I'm kind of touching with my finger, it tucks behind a tab and it fits in a small groove. So you push in and down to lock it in place and push in and up to release the bulb. Here's a diagram from the factory service manual that kind of shows you what they refer to as a spring that holds in the headlight bulb. And finally, here's a short video. The car hasn't been moved. We will show you both Philips headlights installed. My final thoughts on the bulbs are that they're a good purchase. I highly recommend some type of LED headlights. Even with the low beams on, they produce very noticeable light even on a well-lit street, and they do a great job of lighting up the curb and the road ahead. I wouldn't hesitate to buy the cheaper SEALIGHT bulbs, as the reviews on Amazon do seem pretty good, and some of them do appear to be fairly long-term reviews. While you're enjoying my demonstration of the bulbs, I'd like to briefly mention that if you're shopping around for bulbs, you'll notice that some of them have like active cooling, like a fan. If you notice, like when I installed the Philips bulbs, there's really any bulbs, there is no airflow over the heatsink because the dust boot blocks one side of the heatsink. So in some senses, maybe a fan would be a good thing. I'm not too sure long term how these bulbs will hold up, but also remember that in more modern cars, even the Mitsubishi Mirage in some markets has auto stop and go. So if you're in like stop and go traffic, when you stop, the engine turns off. So the coolant will never warm up. So the engine radiator fan may never turn on. So you may have your high beams running for possibly hours on end with zero airflow if you're in stop and go traffic with an auto stop and go engine. Something I never really thought about or thought to test for is that the DRLs, like daytime running lights, which are required by law in Canada, flicker with these Philips LED bulbs. The way DRL works on this car is that it pulses the high beams on and off. So with the halogen, just like an incandescent bulb with the home dimmer, essentially turning the bulb on and off really fast with the high beam would dim the bulb. But with LEDs, it appears like it makes the bulb flicker, and there's no easy or obvious solution to this. So if I was to buy one of those like capacitors or resistors on Amazon that claim to fix this flickering problem, they would stabilize the voltage, sure, but essentially I'd be running the high beams on all the time, which is undesirable for obvious reasons. Thanks for watching. If I have any updates to provide, I'll put them down below in the description.